Okay, go on. Good morning. Your group number 3. Okay.
Yes. Good morning, everyone. We are the group 3, and this is the agenda for today for the progress control presentation. Talking about the Maxwell modeler, we set the WL as 4.5 meters. We set in the baseline at the 0 point and define the aft perpendicular and the forward perpendicular as it's shown in the pictures.
I'm not seeing any figure yet.
You can see the pictures.
No, I cannot see anything.
Sorry.
Now, yeah, go on.
All right. So in the case of the mature stability, we set the tanks in the ships and the fish holes. And this is our phase load case as 50% of consumables and the full fish hold. The input data was set here, and the percentage of the full is right here as it's shown in the table. And it is our results for the hydrostatic analysis.
The second law condition is going to analyze 100% 100 consummates and 10 fish holes. In the same is very important the vertical center of gravity because this value to analyze in the motion section of Maxwell. Next. Of the results that are need the draft of the draft of LCF and the trim. Next. At the point 3, enter the maximum motion. This is important to define the vessel draft and trim. With this data is obtained in any lower condition. The measure hole is with 41 surface cooks because it is a good information. Next. Then we process define the damping factor. This value is obtained with the Jimeno program, but for the moment I'm using the define for the Maxwell for the fall. We select in the mass distribution, this value is for any lower condition. Next. We define for stage 3 or stage 4 for this information is obtained in the PMA of volume 3, and the range of healing is defined of the 0 after 118. Finally, the speed is defined of the range of the 10 speed knots and the 13 knots. Next.
I'm not seeing any projection right now.
Yeah. Finally, we analyze 2 points.
I'm not, Mr. Barba, I'm not seeing any of your projection. I'm not seeing your projection.
We can see, doctor.
Yeah.
I don't know. Where is that?
Start to sharing again.
Okay. Now, yeah. Okay, yeah. Go on.
Finally, we analyze 2 points. Be located in the heading vertical center of gravity but the first is in the mid section and the finally is in the both section. Next.
Okay, so these are the results that we obtain in the irregular waves. Obviously, we work with different velocities and with different angles, but we are going to show only for 180, for 0 degrees, and for 90 degrees. And for the 0 degrees, we realize something, and is that we obtain encounter frequency that is negative. So this is interesting for us because we can know that the waves comes to the aft. Okay, this is for the 90 degrees, and for the regular waves, we obtain the following. In this part, we are going to work this show only for the first loading condition for 13 degrees and for C state 3. So we work with the range with the range that we found in the table. So we have for 0.5 meters the wave amplitude 0.5 meters to 1.25, and for the range of the encounter frequency we put 0.8, and this is for the result for the 90 degrees and for the 120 degrees. So we realize that the wave the length of the wave is large at the end. Thank you.
In the first presentation, in the first control that we developed some week ago, I have written here that you are going to analyze 4 loading conditions, but I've seen only 2.
Yes, doctor, this is our question because in the document that you sent us, you put only 2 loading conditions. So for full and I don't know what is the other, but we can work with the 4 loading conditions. This is not problem.
Okay, I would prefer at least 3. Okay, so yeah, so in order to compare, okay, our interest is always the extremes. So try to include full load, the lowest displacement, and an intermediate condition, so we can see the difference between the 3. Okay, please put some emphasis on the floatability of the ship, right? If you want to compare, for example, in the report you have to clearly show mean draft, trim, kg, or GM if you want. Okay, so we have a general idea of how these loading conditions can be compared. Okay, finally, are you going to present this in ship design, or Barba and Zamora, are you taking ship design?
No, doctor.
We are not.
Okay, so you can present this in the, let's see. Okay, let's go on now to group number, I don't know the number, but the group number 5. Group 5 is here. Manrique, Mantias, and Matute.
Yes, doctor. We here. We need to project.
Matthias is here, Matthias. Oh yeah, and Matute, please turn on your cameras, people. If you are going to speak, I want to see your faces, okay?
Okay,
For
doctor.
those of you who are going to present, you have to have your camera on. Go on.
Doctor, I changed my oh, okay, my good is
No, yeah, Violetita 3.
okay, yeah.
Good morning. We are group 5 by Matriarnal Emanuele in this progress control, we will present the regular way response using Maxwell. Next. Here in this table are the main images of the Violetita dot. Next slide. As I mentioned in the last presentation, our chip has 5 defense and 6 hot. 9 items are located in the forepart. The 6 hot are in the mid. Next slide. These 10 are located in the upper. This distribution was used to analyze if maximum stability in two load conditions and 105%. And then with the result obtained, the chip is analyzed in maximum mode.
Now we model the hole in the Rhino and the surface input in the modeler MaxSurf and define the type of chip and draft.
Cannot see your projection, Matute.
Can you see?
No, I cannot see anything.
No. One moment.
I see the projection.
Now,
Now I can see it.
okay. In MaxSurf stability, I consider two load conditions. In the first condition is the 100% storage, and this value input the load case and compare the value in the kg and the weight in the original data in the stability boot, and this value are close. With data input in the MaxSurf motion is the value, the draft, and the kg. Are there?
I can see the next slide.
Yes, yes.
Well, the tank's conditions just to be analyzed two conditions because in the document just to be mentioned two conditions. The first is when the ship is total percent of the tanks, and the second we analyze to the half percent of the tanks. Next, please. And we want to
If you can, for comparison situation, it will be a good idea if you include 3 loading conditions. Okay, if you can present results for 3 loading conditions.
Oh, okay, doctor. I want to yes. The next, please. So this is the result of the MaxSurf motion. We want to.
I cannot see anything. Would you please check that? I cannot see your results.
Really?
Yeah.
I see the results, the location, heating, and CS state.
Okay, describe them then. At least describe them because I don't want to waste any more time. Go on. So
Okay, just to be
describe me what you're seeing.
we want to continue the situation in the video. So this is the condition we want to put in the maximum motion and the analyze of the hill on the of the wave of 0, 90 and 108 grades. And this is the last slide, please.
This is a general comment. People, if you want to analyze waves coming from different directions, it would be a good idea if you analyze with more with
Conditions.
closer directions. Yes, not only from 0, 90, and 180. It could be a good idea if you include, for example, every 30 degrees, 0, 30, 60, and so on. Because in general, we need to do some integrations, right? And if you have only 0, 90, and 180, the integration, it's not going to give us good results. I think when you include more closer values, 0, 30, and so on, maybe the integration will give us a more better results. Okay, go on. I'm sorry for the interruption. Okay.
This is all. Thanks, Doctor.
Are you going to present this in ship design, Mr. Manrique? Are you going to present this result in ship design, or are you taking ship design?
In ship design, yes, but we want to present with Kelly Drogo.
Oh man.
It's all, yeah, it's other ship.
So
we present to the
Manrique is in ship design. Is that correct?
Yes.
And how about Matute? Are you taking ship design?
Yes, Doctor. I take this class.
And you're going to present with whom?
Sorry.
Are you going to present the ship design project in the technical sessions next week?
Oh no.
You have to. Everybody in ship design has to present results. It's an obligation. Matthias, are you taking ship design?
No,
Okay, no. So it's only Manrique and Matute. Okay, good. Okay, good. Do you have any question for me? People, do you have any question for me?
No, Doctor.
No, thank you.
Thanks.
No problem. Let's see. Let's go on now to next one is group 8. 8 is here.
Yes, doctor. Good morning.
Okay, go on.
Okay, good morning, everyone. We're going to present our advance about regular waves response. So go on, Thais, please. This is the little agenda we prepared today. First, we will remember the main characteristics of our ship. Then we will show you how we did the 3D model in Rhino. Then we will explain what we did with MaxSurf modeler and then stability, and finally what we did in motion. So the objectives of this advance were to create the 3D model of the hull of the YS2 tugboat. Then we use MaxSurf modeler and then stability to get the load cases for the 2 conditions that we were asked for. Now we understand we have to include one more, but we work here with 100 and 50%. And finally, we had to evaluate the ship response in regular waves for the different sea states that we were asked for, that were 3 and 4 in the Douglas scale. So just to remember the main characteristics, the main ones were the length, that is 34.95 meters, the draft, that is 3 meters, and velocity, that is 12 knots. So this is the 3D model that we did in Rhino. As you can see, it had 2 surfaces, and we use this to go to MaxSurf Modeler. We input the draft and the length between perpendiculars, and then we go to MaxSurf Stability.
Good morning, everybody. To the maximum stability, we're going to take the distribution from the plan. From the original sheet, we can establish the log condition for each case. In this distribution, we can see the four peak, the tanks on the fluid and the ballast tank on the weight. And we can see in the next slide, we can see the log condition for each case from the 100% and 50-100%. Here we can note that we have reduced the displacement and 13% from the original condition. From this analysis for the stability, we can take these values kg draft on the forward and draft on the after, and displacement in both low case. When we get
I stopped seeing your presentation. Please, I cannot see your presentation. Mr. Jimenez?
Let me share again.
Mr. Friday show the presentation.
Okay.
Can you see now?
Yeah, I can see now.
Yes, doctor.
Yeah.
From this value, we take to the model motion to MaxSurf to analyze the regular weights on the next slide. Thanks.
For the analysis on the MaxSurf motion, we consider as it was given the C state number 3 and 4, which in the default number, it's the number 4 and 5. We also determine the natural frequency for each load case, and also the different velocities that we will consider.
These natural frequencies is for what motion are these? Heave or pitch or raw?
We found the natural frequency only with the GMT for each load condition.
So that's raw, probably. Yeah, okay. That's something that we have to be, I mean, we have to be careful because in general, we have 3 motions here. So when you say something like natural frequency, you should refer to any specific motion because there are 3 different values, right? You talk about heave, pitch, or raw, and each one has a different frequency. So that's all. You have to be careful with that.
Okay.
Go on.
Okay. Well, then we put the model on the MaxSurf motion, and we consider 41 map sections. Up to now, we have obtained the RAW's response. This is for the load case number 1, and on the left side, we consider for 90 degrees. We can see the response on road are the higher as it was expected, and for the 180 degrees is the heave, the more considered.
Yeah, makes sense.
Response. Yeah, the similar thing happens in the load case 2. For the 90 degrees, we can see the raw, and for the 180 is the heave and the pitch, and the raw it's like very, very low.
This route from the added resistance is very interesting because I see some peaks. I see some peaks every certain value of frequency. That will, I mean, it could be a good idea, a good recommendation for you. Try to explain why do we have these peaks in the added resistance, okay? Try
Okay.
to see if you can explain that for the final report, okay?
Okay.
Go on.
And then we did the simulation and we consider for the beam waves, the encounter frequency. And here is the pictures. And for the 180, we consider the encounter frequency for that angle. And we can, it's not really clear, the picture, but
Mhm.
it's, this one is advanced, and the conclusions, well, we can see that the maximum amplitude doesn't coincide with the natural frequency, well, this for the rolling. And for the 180 degrees, the heave on the pitch corresponds to the higher. And we also realized that for the load case condition, the response is like higher, higher values on heave and on the roll. Thanks.
Yeah, you have to be very careful with your comment because usually we should expect to have the largest response at the resonance. Okay, so we have to be careful with your comment, right? Because you are like breaking a rule, right? So we have to be more precise, maybe, or write it in a slightly different way. Because if you affirm that on resonance you have lower response that at resonance, then yeah, it's a new knowledge probably. So be careful with that comment.
But how
Okay.
I don't understand that comment. You are saying that, yeah.
That's all. That's all.
Okay.
About the other resistance, okay, I saw that there was some peaks, then there was a reduction, another peak, another peak, another peak. It would be a good idea if you review just a little bit of the literature and try to explain why we have several of these peaks. It is possible that that is explained when you have a relationship between the length of the wave and the length of the ship, right? Okay, if you have a wavelength which is about the length of the ship, it's possible that you have an increment in resistance. Makes some sense, but you have to look for it in the literature and try to explain that in the report. Okay, good, good. Let's go on now with, I think it's group 4, right? Group 4 is Astudillo and Ramon are here.
Yes, doctor.
Okay, go on, please.
Can you see full screen?
Yeah, I can see your full screen.
Okay, good morning, doctor. Good morning, classmate. The topic
Just a second, just a general observation. My name is Jose. You have a tilde in the E, okay? And people, when you present something like this, I don't like to see my title. I know what my title is, okay? So the instructor is just Jose Rolando Marin L, and that's all. Do not include my title, please. Okay, go on, please. I'm sorry to interrupt you.
Okay, doctor, no problem. The topic about is true response to regular wave of the coastal factor vessel. The next, please. Okay, the content. The first is the main dimension, the second is stability and result, the three are load condition, and four is regular wave results in motion. The next, please. Okay, in the main dimension, we ship is have a length 49 meters, is a velocity ships, and the maximum velocity, the maximum speed is 25 knots. The wing is 7.8 meters, the depth is 40.45 meters, and the draft is 1.64 meters. Next, please. We have a velocity ship. We it's necessary for me split that the cost of vessel in the strength of the bottom is very plain because the system of propulsion of the ship is a water jet, and the specific design condition is that the stern is only planed. The next, please. Okay, we have two load conditions. The first condition is when the ship exit the port is 95% of the load, and the second condition is when the ship arrived at the Galapagos and the 50% condition of the load. The next, please. Okay, and we analyze the criterion of stability in MaxSource, specific the criterion of IMO, and pass all the criteria, and they analyze the floating length and put in the buttons.
Yes, when my classmates talk about the cloud condition, we put the 95% in the first diesel, first water, oil, and full oil for the machinery, and 10% for the tanks of wastewater, dirty water, and others residuals processors. And the load condition too, we put the 50% of all, but in the balance is 90%. This is our distribution of tanks and the disclose of the weights of we use to in this project. When you use MaxSurf motion in regular ways, the first we import from MaxSurf our model and obtain the first graph. Then finally, when we reproduce in regular waves, we have to animation of what is the component of our ship in regular wave selected, in the encounter frequency selected. The parameters of our analysis is the following. Sorry. The first is locations. We analyze the common bright and the halo station, and the speeds are maximum is 25 knots, minimum 12 knots, and the cruise of 15 knots. The angles we analyze is 0, 45, 90, 135, and 180 degrees. And
just let me interrupt you, Mrs. Tudillo. And this is for everybody. Okay, when you consider heatings, please, you have to include more heatings. Okay, spacing between heating and recommended value is 30. Okay, because we have to consider integration. Okay, so it's better if you have closer heatings. Okay, so instead of 0, 45, and 90, we should do 0, 30, 60, and 90. Okay, and so on until 180. Okay. Okay, go on.
The spectra selected is C state 3 and 4, but in our case we can't add the sea state 5 for Galapagos Islands. This is our result around in 45 and 25 nodes, and sea state 3 in 0, 90, and 108% degrees, sorry. And this is around in condition 2 in 0, 90, and 108% degrees.
Here, let me do a correction here. If we present result for the raw calculation, we cannot say anything about sea state because raw is independent of the sea state. Okay, so these results are for a velocity of 25 knots, loading condition 2, but it's not, makes no sense to say this, to mention any sea state. Okay, When you combine the raw and the C state, you obtain the spectral density of the response, but that's something different, okay?
Okay, doctor, sorry.
Go on. No, but you don't need to say sorry. That's all.
Okay.
Let me go back just a little bit because I want to, okay, let's see. Okay, go on.
Okay, finally, we analyze the MSY, that is motion
MSI,
sickness
yeah, okay.
index, that evaluate the comfort of the passenger in the in comfort of the passenger movement. This values is according to the ISO, and we can see that in 0 and 90% the passengers don't have in comfort, but in 100%, 80
Yeah.
degrees have a little bit.
Yeah, in your case, it would be very interesting to see the response at the helo, at the helicopter platform, okay?
Okay, doctor.
Right? Yeah, I saw that's a point that you have to analyze. It's going to be very interesting, okay, to see the response of the platform, because if the ship moves a lot, the helicopter cannot land or depart. So it's going to be very interesting in what conditions this operation can be completed. Are you going to present this in ship design?
Yes, doctor.
Okay, so you're going to. Okay, good.
Okay,
Let's,
and then in second condition, the same of the first, and the results are very close
mhm.
in the both conditions. Thank you.
Okay, good. Let's move to to group 6, Ms. Lopez and Mr. Galarza, I think. Lopez and Galarza
Yes,
are
doctor.
here.
Yeah, good morning, doctor.
Let's see, is Lopez here?
Yeah.
Okay, would you please turn on your camera? Everybody, when you participate, you have to have your camera on because I would like to see your face. Go on.
Good morning, everyone. We're talking about the preliminary design of a
Ms. Lopez, let's to improve, okay? When you start saying, you have to say something like, I am going to talk about, okay? That's the correct way to mention that. Okay, go on, please.
We're talking about.
No, we're talking about, no, I am going to talk about. Go on.
I am talking about the preliminary design of a 63 meter hull capacity fishing vessel. We, the group number 6. The agenda is introduction, model, observe, and results. The main dimensions of time from the optimization shown in the following table, and the modeling generator in generating in ring. And the line spline of time from the Rhino. The general distribution of the fish tanks, full tanks, water, hydraulic oil tanks, drop tanks, ability, foods, and warehouse. And the analysis for the load case. The first load case of the whole 10% and consumables 100%. The displacement for the analysis is 86 tons and kg 4.25 meters, and the second case is called 50% and consumables.
Ms. Lopez, let me interrupt you. One recommendation for everybody, when you present these results, okay, don't try to present too much information because, I mean, there is a lot of numbers here, right? And I don't see, so try to summarize that, okay? So instead of putting each load case with such a large table, just present one single table with a summary of each one of the conditions, right? maybe you can add a little bit showing some detail, but not too much because see, you are not explaining this table. So there is no point in presenting something that you're not going to explain. Something else, okay, about the kg calculation. It's a good idea, right? Okay, you give me 4.25, but how good is that estimation? Okay, one way what we can do is either you can divide the kg, divide that by the draft, or divide that by the depth of the hole. Okay, or maybe you can include also the GM, because the GM it's can be interpreted as a moment per unit displacement, per unit angle of inclination. So in general, the GM can be considered as a specific parameter. So you can compare directly the GM for any ship because it's independent of the size of the ship. Okay, so either please do that. Okay, when you present the kg, try to present as a quotient with respect to the depth of the ship, or include also the GM. Okay, yes, go on.
And next slide for the GM.
Okay.
The GM for the load condition, the first is satisfactory and the second acceptable.
Acceptable. Okay.
Acceptable.
104 is a large GM for the fishing vessel in general. Okay. Go on.
Yeah.
All right, for the Maxwell analysis in regular wave, we consider that two sea states, 3 and 4, we have the wave height and the period. And we consider also three velocities.
I'm not seeing your projection. Can you check that, please?
Oh, can you share again, please, Michelle?
Please, Ms. Lopez.
Can you see it now, Doctor?
Yeah, I can see now. So,
okay, so we consider three velocities, 10, 12, and 15 knots. 15 is the maximum velocity of the design. And for the incoming waves, we also consider 5 direction. But as you say, we have to add more.
Yeah, okay, good.
Okay.
Also, please,
yeah, so
just a simple correction. When you say, when you mention wave height, okay, that I would need to include you more details. Is this average? Is maximum?
All right, I got it.
Okay, or whatever. Yeah, you have to be, and also for the period. Okay, sometimes you find it as a model period or an average period, but you please include the full information so we can have a better idea of the sea state. Go on. I'm sorry.
Okay. Okay. Yeah, next one, please. Next slide. Okay, so for the load case number 1, we consider 2 points of analysis, the COFA and the bridge. So you can see the points in the because I mean the highest point of the
I know.
ship.
It's gonna be interesting.
Yeah, it is like 25 meters from the baseline.
Yeah,
so,
yeah, and
it's higher point.
it could be a good idea if you try to find information for the allowable values for that, because I would expect to move a lot. Go on.
It is. Yeah, then for that, the strip theory method is applied, Maxwell. Yeah, for the load case number 1, we obtained these routes. We realized that in 180 degrees and 135 degrees, the ship was in resonance because we have the largest amplitude in the route.
Yeah.
So you can see the roll route is higher in 180, and this is the graph of the motion sickness incidence.
Yeah, of course.
So for that reason, I just put here this graph from these degrees, because in the other degrees from 0 to 90 was really lower. So
yeah,
that's the reason. Next one, please.
Now, in this case, when you analyze a fishing vessel, we have to be careful because the MSI, okay, it's not that important unless it's the analysis of the COFA. Because when you come to a fishing vessel to work as in a fishing vessel, you're assumed, okay, to sustain a lot of motion. So
All
MSI,
right.
I don't think it's that important. But it would
Okay.
be a nice idea in this case if you consider the response at the COFA, because it's an
Yeah, I'm
extremes.
trying to be up there for a lot of time. Next
Okay.
one, please. Yeah, and for lot case 2, we have the graph here too. Also, the ship is in resonance at these degrees. So we can see the roll route, the added inertia, and the hip route. The pitch
Okay.
roll is the lowest. And the next one, please. These are the motion sickness incidents. Also for these two angles is in resonance. So you can see that the COFA is lower than the bridge. I don't know how it happens, but it
Well,
shows in the graph.
it is possible that the COFA probably moves a lot in a transverse direction, right? Because
Oh,
with the
yeah,
roll motion, you will move in the y direction. And
yeah.
it's been found that the acceleration in the vertical direction is responsible for the motion sickness index. So
Okay,
if you move in the lateral direction, it is possible that they don't move quite a lot.
too
But
much.
in general, you could calculate is the acceleration, the lateral acceleration at the COFA. Maybe you could try to find any value for that parameter.
All
Okay.
right, we should check that.
Okay.
And finally, we just check the Ohm criteria. For that reason, for that, we use chapter number 2, the general criteria of intact stability, and the recommendation for fishing vessels of the part B of the Ohm. And it passes all the parameters, and we just check that. It's shown in the next table, but we should summarize that.
Okay, yeah, this is something which is also very, I mean, we can discuss a lot because fishing vessels, they do not comply any specific IMO criteria because they, in general, there was an intent, a trial, in trying to specify a certain stability requirements for fishing vessels, but unfortunately, it didn't pass. So yeah, I mean, when you evaluate the stability of fishing vessels, it's something that people do not comply with everything because it's a very special situation. Okay, Gomez, Lopez and Galarza, are you going to participate with this project in the ship design course?
Yeah, okay.
Okay, so you
Yeah.
are presenting this design in the ship design course.
Yes.
Okay, so yeah, fine. Okay, let's go on to group number 7. Group number 7, Carrillo and Iñiguez are here.
Yes.
Go on.
Good morning, everybody. Good morning, doctor. We have the presentation group 7. My name is Luis Carrillo. My partner is Josue Iñiguez. We had a
Just a second, please. When you say, I don't think partner is a correct word. I think it's my teammate is better. Okay? Go on, sorry. Just was a curiosity, Mr. Iñiguez. In your name, Josue, don't you need a tilde in the E? Josue? Mr. Iñiguez, can you hear me? In your
Yes,
name,
doctor.
Josue, don't you need a tilde in the E? No?
I don't have till.
Okay. Okay, go on. Sorry. Go on, Mr. Carrillo.
well, next baby, please. Wait, I have my ship is Booker ship. I have you can show where the main characteristic, for example, the length being a draft, other the speed, volume, the bunker, other dates. Next step, next step, please. Next. You can show the following line plane. I can show the 3D, the characteristic, the ship. I have the next, please. Well, I have this is three conditions we can work. The full consumable, we have the car and gas tank as 100%. The port, we have the car 0 and the gas tank 100%. 15% of consumable, we have the car 50%.
Okay, people, just a second, just a suggestion, people. When you present something like this, it's a good idea if you include the displacement, the vertical kg or with respect to the depth of the ship, something like that, in order that we can see the differences in total displacement between these conditions. Okay, so for everybody.
Yes, we have this is date. I forgot the intros.
Okay, no problem. Just a suggestion. That's why we need these checks. Okay, so we can improve the final presentation. Go on.
Well, next.
Okay, in this part, I work in maximum stability and got the RAP. After I verify the solar requirements are met that you can see in the table. In the next step, I work in maximum motion. I put this speed that you can see. I am working with the state 3 and 4 and with an angle step of 22 point.
Okay, that's a good asynchronous because in this case we can see the difference, the variation. Okay, good.
Okay, yeah, I got this graph in 19 degrees that you can see the high response is in the route is 0.5, 0.7. Sorry.
Yeah, that's a resonance, definitely.
Now,
here, what value did you use for damping? That's, remember, it's critical, the damping. What value did you use for damping?
0.00008.
Yeah, but you have to calculate that using Imeno or any other method, okay? We cannot simply assume a value. You have to calculate that. But I can see that it's a large response. Yeah, the resonance is a big problem. Okay.
In the next graph, I got it the
180. That's from, yeah, of course, makes sense that you have a heave, very high heave. And the roll in RAW, basically there's nothing. Yeah, so there is no resonance. Yeah, when you receive the waves from the fore end, yeah, there is no resonance in RAW. Makes sense. Makes sense.
Okay. I don't work in the under condition, but it's the same step will be repeated. Thank you. I just working with the first condition.
Okay, good. Yeah. Okay. Yeah. It looks okay. Okay. And I'm really glad that you are going to consider situation when you have zero velocity, right? But because I think in your case, this ship will be probably delivering some cargo with no velocity. And the problem is that when you have no velocity, usually the damping coefficient decreases. So if the damping decreases, you can expect an increment in response. So it's going to be a good idea if you analyze the response when you have no velocity, okay?
Okay.
So this is very important. Are you going to present this project in ship design, people? Are you taking ship design?
Yeah, me.
So only you, not Carrillo?
No, Carrillo.
Yes, I mean.
So Iñiguez is going to present in ship design, right?
Yes.
Okay, good. Thank you. Okay, let's go move to group number 2, Gutenberg and Vega.
Good morning, doctor.
Okay, go
You
on.
can see my, okay. Good
Can
morning.
you see? Can you see? This is a
Can you
question,
see?
right? So you say, can you see? Go on.
Can you see? Okay, good morning. We are the group number 2. The project will be developed by the launching a pilot vessel with the following main characteristics. This is the length, 15.7 meters, and the depth is 2 meters. The speed, the max speed is the 27 knots. This is the planar forms of the pilot boat. Okay, from the general distribution of the boat, the different types of tank responding to the fuel, fresh water, slopes, and ballast. Two conditions are analyzed. The first is considering 100 consumables. This is a 95 of the fuel and 10, the permeability is the 95 of the fuel and 10% of the slopes. And the first conditions is the 7% of consumables and 10% of load. This is the vessel of passengers. The load is considered 8 person in total, and the second conditions we analyze 5% of consumables and 10% of the load.
Just one observation. I see that the displacement in condition 1 is 51.3 tons, and in condition 2 is 48.6. So the difference between these two loading conditions are very small. Okay, you should look for another condition with probably maybe the consumables at 10% and reduce a little bit the load. So we can see the difference in loading condition, because 3 tons, less than 3 tons, don't make much of a difference. Okay?
Yeah. Okay, thank you. To analyze the condition in the model motion of Maxur, we enter the trim of the vessel, the mass distribution. This is the center of gravity, and the damping environment and frequency range. We select the value of the full.
Okay, in here, people, this is something for everybody. In your report, you have to show me how to evaluate the non-dimensional damping coefficient using Imeno for the raw, okay? Everybody should calculate that using any method. The easiest way to evaluate that is Imeno, but you have to show me. I'm not going to pass that. I'm not going to accept just a guess. You have to calculate that value, okay? Go on.
Okay, and next we put this data. We select the location, speeds, heatings, and see expected. In the location, we consider 1 point in the kg, but we need consider the point in the superstructure, specifically when the passengers stay. We have a through velocity, the maximum, the cruise and patrolling. We consider 7 degrees, and this boat navigate in sea state of 3 and 4.
Result the maximum motion and the irregular waves. We have for the 27 knots. The next.
Just 1 second, because I see that Maxorf calculates an added resistance. Okay, I see that you calculate added resistance in kilonewtons. Okay, this parameter is very interesting, very important. Okay, so we could add, consider this parameter, I mean, the change in resistance when you navigate in irregular waves. Okay, so I see that, what are these columns? For example, for the added resistance, I see 4.063 kilonewtons. And when you move to the right, okay, I see 2.109. What is that number?
I'm sorry.
109. What is that number? And parentheses 2.98. What is that?
Yes, I don't remember.
Don't remember. Okay, so please try to explain that in the next presentation. Okay.
Okay.
Okay, go on. Yeah, because it's very interesting, this parameter.
In this graphic, I can see the response of the response and on the raw and spectral. This graphic is for the 118 degree.
Yeah, so
next. And the second, for the second condition, there is the variables and the draft. In this point, we can analyze the kg, the position, and with the equal parameters. And this is equal.
Sorry.
Is the response of only the speed vessel 27 knots.
yeah, in this case, it will be very interesting if you change the velocity, okay? Because it will be very interesting to see how the velocity influences the response of the ship in waves. It will be very interesting.
And the same is the response of the answer and the spectral for the second condition.
Okay.
And this is the result of the regular waves. Consider the frequency,
wow.
the 3.53 rad over second, and the amplitude of the wave of the 0.50 meters.
Wow, that's a small wave, and it's still the ship moves a lot.
Yes.
Yeah.
But if we consider the 1 meter.
Yeah, so probably you have very close to resonance.
Yes.
That's a problem. Okay.
Thank
you.
You're welcome. Okay. So let's move to the last one, group 1. It's here, group 1.
Yes, doctor, good morning.
Good morning. Gutenberg and Vega, you're not going to participate in ship design, right? You're not taking ship design.
No.
Okay. Okay.
Okay.
Yeah, go on, please.
Good morning, everyone. My name is Paul Zambrano, and we're confirmed by Kelly Drobo, Jonathan Delgado, and myself. In this first advance, I will present the ship motion due to regular waves in 2 different load conditions. The agenda that we're going to be presenting is the following one. The main characteristics of our ship are the following ones. The owner of the ship requires a yacht with a length of no more than 40 meters and with a habitability area for 16 passenger and 10 crewmates. For this advance, we need to analyze the response of our chip for regular waves for the CS states 3 and 4. For that, we're going to start using the MaxSurf modeler to input the frame of reference. And then we have to establish the compartments and the general arrangement for the tanks in order to get the center of gravity and the draft forward perpendicular and after perpendicular. Those values we're going to need to input in the MaxSurf motion.
We have two different load cases. The first one is 100% of the consumables, and the second one is the 50%. So as you can see here, this kind of distribution or about our tanks inside of the ship. Next, please. This is the results after to set our model in MaxSurf stability. So we get the KG and the GMT. As you can see between the two load cases, the KG, the second one, rise up. So it makes sense because we lose some weight. And the GMT.
Just one observation, Miss Hidrobo. I see that the draft at the forward perpendicular is larger than at the aft. That means that you have a negative frame. I don't like that. I prefer to have more draft at the aft end. Okay, so pay attention to that. Okay, right now, okay, I'm not going to say that it is incorrect for ship dynamics. Okay. But in general, I don't think the ship owner likes that situation. We prefer to have more draft on the aft end than on the forward end. Okay, go on. And it's similar for the second loading case. Okay, go on.
Yeah, I will have to check that.
Okay, go on.
And the states we work for the states 2 and 3 and 4. Here this is a height and average height and average period for each corresponds to state.
Again, when you say this height of the wave, you have to mention, is this what, mean height or average of the one time highest or whatever? Similar for the period, okay? Because we need to have a good idea of those numbers. Okay, so when you present the C state, you say height. Okay, what is that? Is that mean height or whatever? But you need to be clearly specified. Go on. I'm sorry.
Okay, got it. No problem. So as a results, after to set our model in motion, the next one, please. We get these results, as we can see here, before when we have the wave coming from the beam, the response, the route, it's the higher one. That makes sense.
Very high.
Yeah, it's very high. And this is for each load case to compare.
In your case, I'm sorry to interrupt you again. In your case, okay, it's obvious that we need to do something about this, okay? In your case, I would suggest that you include, I don't know, you have to talk to Dr. Dominguez about this, but you should include beach keels, okay?
Yeah,
and in that case,
this is one of our recommendation.
Yeah, you have to include that, and you have to consider that when you estimate the damping coefficient in rho, in order to try to reduce a little bit this route. Okay, go on.
Okay, my partner, it's the next one.
Go on.
Okay, as we can see, employing the load condition mentioned at angle 100H with both wave in both conditions in CS state 3. We have a frequency of encounter. It does not present the grid response, high response amplitude, as I can see in this graph. Okay, next slide, please. Okay, in this case, we considering the load condition when using a range frequency in the CI state 3. Analyzing waves that come to that come from side.
Mr. Delgado, just one comment, okay? If you are I can read the title of your presentation. It says regular waves. When you mention regular waves, that means that you cannot say anything about the C state, because when you say C state, that's irregular wave situation. Go on, I'm sorry.
Okay, wait. Well, in this case, we consider wave come in 19 degrees. With yes, okay.
You are in trouble.
Yes.
You receive waves from the side, from the beam. Yeah, it's a big.
Okay, next slide. Well, in conclusion, we have the maximum amplitude of the response that does not coincide with natural frequency of the ship. And the maximum amplitude are due to lower frequency. The high response are encountered in roll motion, and the dot case 2 present a higher response.
Okay, here we have to be careful with the first conclusion, okay? We are presenting a progress and we are doing a control, and you have to be cautious with this affirmation, okay? Because usually we expect the largest response at the resonance, and you're saying that you're not having that. So probably it needs to be written in a slightly different way, because that's something which usually is not mathematically correct. Okay.
Thank you.
Your case, let me insist, people, in your case, that you have to include bilge kills. And to estimate the damping coefficient, you have to use Imeno. And in Imeno, you could find a possibility of including bilge kill. So the damping coefficient will include the influence of this device, okay? Because otherwise, when you receive waves from the side, from the beam, the response will be very high, okay? That's something. Okay, are you going to present these results in your ship design? Are you taking ship design, Zambrano, Delgado, and Hidrobo? Are you taking ship design?
Yes.
Okay.
Yes, doctor. I'm going to present my project.
Okay, so, and the three are working in this project or different projects?
No, I'm not. I'm with my
working on this one for ship design.
Zambrano, say that again, please.
Just me and Delgado are working in this ship for ship
And
design.
Hidrobo, you are working with in ship design?
Manrique in another project in ship design.
Okay, so the three of you are working in ship design. Okay, good. Okay, people, thank you for your participation, and it's a good idea that you practice. So at the end, when you do the final presentation, it will be there will be some improvement in your presentation. I'm going to make some summary of some of the comments that I make here, so for everybody will have take note of that. Okay, good. Have a nice weekend. Oh no, I'll see you tomorrow. Bye bye now.